Now we will talk about continuous functions. We will solve some questions about continuity and discontinuity. A function f of x is said to be a continuous function at the point x equals a if limit of f of x as x approaches a exists, and this is equal to f of a, the image of number a under the function f. A function is said to be continuous on the interval a comma b if it is continuous at each point in the interval. And we can get one conclusion that if f of x is continuous at a given point, then limit of f of x exists. It means that the left side limit and right side limits both exist and equal to each other, and this is equal to f of a. Now, when we look at these graphs, what can we say about that? Of the 5 graphs below, which shows a function that is continuous at x equals a. So when we talk about these questions, since it's clear that when we approach the number a from the right side and when we approach the a from the left side limit is here, the right side limit is here. So right hand side limit is different than left hand side limit, so does not exist, limit doesn't exist. And here when we look at from the right side f of x goes infinitive, from the left side f of x goes the infinitive, so limit of the function f of x is equal to infinitive, and infinitive means limit does not exist. And then here, since the limit doesn't exist here and here, we can say that the function is not continuous function. And at this point, when we approach the number a from the right side, the limit is L. From the left side, limit is L. So let me write here, limit as x approaches a minus is equal to limit as x approaching a plus, which is equal to L for the given function f of x. Here there is f of x, here there's f of x. But f of a is undefined. So definition says that limit must exist when x approaches to a, and this must be equal to f of a. So for that reason, this function is not continuous function. When I look at here on the right hand side and on the left hand side, limits are equal to L, but f of a is equal to m, and limit of f of x is equal to L as x approaches a. Since m and L are different to each other, the function is not continuous function. But here on the right hand side and on the left hand side, limit is equal to L and f of a is equal to L. Only graph 5 is continuous, all the others are discontinuous functions. When we look at this question, the graph of f of x is given. Based on this graph, determine where the function is discontinuous. So it's clear that when the x equal to -4, the function is discontinuous. Since the right limit is equal to, let me write here, limit as x approaches to -4 from the right, f of x is equal to -2, and this is different than limit as x approaches -4 from minus f of x, which is equal to, it's +3. So -2 is different than 3, limit does not exist. Yes, we have the right hand side limit, we have the left hand side limit, but since they are not equal to each other, the function doesn't have limit. If the function doesn't have a limit, it's not continuous. And when we look at here, there is no problem since right side, left side, and the function itself, between them everything is fine. But here when x approaches 2 from right and left, one of the limit is -1 and the other one is 5. So -1 is different than 5. For that reason, when x is 2, the function is discontinuous. And similarly here, when x approaches to 4, when x approaches to 4 from the right and left, so limit of f of x when x approaches to 4 exists, which is equal to 2, but f of 4 is undefined. So since f of 4 is undefined, the function at x equals 4 is discontinuous. All the other points, our function is continuous. Or we can say that the function is continuous everywhere except the points -4, 2, and +4. Yeah, now when we look at this kind of question, these are the famous question type. Even in the university, in the first year, you will see this kind of question in your midterm or final exam. So it says that if the function is continuous, find a plus b. So we have to know that if the function is continuous, limit of f of x at the given point must be equal to f at a. So in our question, when we look at here what we see, so x is 4, I can say that when x is 4, f of 4 is equal to b. So limit as x approaches 4 from the right side, f of x is equal to limit x approaches to 4 plus, which will be a x squared plus 1. So when I substitute instead of x4, this is equal to a times 4 squared plus 1, which is 16a plus 1. So this is the right hand side limit. And similarly, left hand side limit of f of x. So will be, sorry, this is the left hand side limit what we have done. Now right hand side limit, which is x is greater than 4. So you know that when 4 is here, this side is which is less than 4, we are approaching from the left side. We call left hand side limit. And when we approach number 4 from the right hand side, like 4.001, this is called right hand side limit. So right hand side limit when x values are greater than 4. So my function will be limit as x approach 4 plus 3x minus 1. So this will be directly 3 times 4 minus 1. So which is equal to 12 minus 1, 11. Since the function is continuous function, 11 must be equal to b and it must be equal to 16a plus 1. So it is directly seen that e is 11. So how can I find a? So 16a plus 1, 11. 16a is equal to 10. So a is equal to 10 over 16. And then the question is find a plus b. So 10 over 16 plus 11, which will be, let me calculate here. So 176 plus 10, 186 divided by 16. And then we can simplify. Actually, it was maybe better to simplify here at the beginning. So it was 5 over 8 plus 11. But anyway, so we can simplify and continue. I think that's enough. So the similar logic, if k of x is continuous function, find c. So since the function is continuous function, I will say this one, limit as x approaches to 2 minus of f of x is equal to limit as x approaches to 2 plus f of x is equal to f of 2. And so in my question, the left hand side limit, when I approach number 2 from the left side, this will be, so 10 minus x, so limit of this will be directly 10 minus, let me write it, limit x approaches to 2 minus 10 minus x. So this is 10 minus 2, which is equal to 8. And then limit as x approaches 2 plus, so it will be this case, which is x is greater than 2. So it will be cx squared plus 1. Whenever we see x, we will put 2. So c times 4 plus 1, which will be 4c plus 1. So, and f of 2, if we calculate, f of 2 is, when x is 2, so it is equal to c times 2 squared plus 1, which is 4c plus 1. And so what we say, 4c plus 1 must be equal to 8. And so 4c is equal to 7, c is equal to 7 over 8, and that's the answer of the question. That's it. Determine the functions whether continuous or not. So we should keep in our mind that if the functions are continuous, how can we understand? So whenever we have px over qx, okay, rational function, polynomial functions, where the qx is equal to 0, f of x is discontinuous. So all the other cases f of x is continuous. So when I look at this question, x plus 2, so x plus 2 is equal to 0, x is equal to negative 2. So my function is continuous everywhere except x equals negative 2. Determine the given function whether continuous or not. So since x minus 2 makes my function is undefined, so this function it's not continuous, or I can say that it is continuous everywhere except x equals negative 2. And similarly this one here, the thing is a little bit changed. When I look at here numerator, x minus 2 times x plus 2 divided by x minus 2, and when I simplify, so my function will be x plus 2, which will be everywhere it's defined. So in the previous question I can directly discontinuous, and now this function is continuous everywhere. Why continuous everywhere? There is no case makes my function undefined. What about here? So x minus 3 is greater than or equal to 0. X is greater than or equal to 3. This is its domain. So what can I say? The function is continuous where x values are greater than or equal to 3. Otherwise, it is not continuous. And whenever we have the polynomial function, guys, directly you can say that it is continuous everywhere, since there is no x makes this undefined. So simply to sum up, whenever you have px over qx, if the function is defined for all the real numbers, then the function is continuous. But if it's not defined for all real numbers, so it is not continuous, it is discontinuous. So the first case is it's discontinuous, x is equal to negative 2, otherwise it is continuous. Here x is greater than or equal to 3, everywhere continuous, but except this. For example, if you take x is 2, it will be undefined. Since it will be undefined, it will be discontinuous. Simply, if function is undefined, it is discontinuous. If it is defined everywhere, so it is continuous everywhere. So what about this question? To solve this question like a first two question, I will use the same logic. If f of x is continuous, so it says that limit x approaches to 1 minus f of x must be equal to limit as x approaches to 1 plus f of x, and this is equal to f of 1. So how can I solve the question? The left limit, you know that this one, so I can say that limit as x approaches 1 minus, it will be 3x plus n over x minus 1, and this will be here. Be careful, when I put the number 1 directly here, it will be 0. So since it's continuous, this is a problem. I mean, there should be removable discontinuity. I mean that there should be something in the numerator that we can simplify the x minus 1, so there will be no problem. So how can I solve this question then? I can say that, by the way, when I look at it here, since the limit exists, so let me wait a little bit. I will continue like this. Limit x1 plus, so it will be this case, which is logarithm to 5x plus k. So this is equal to directly, when I put the 1 instead of x, it will be logarithm 5 times 1 plus k to the base of 2, which will be logarithm to the base of 2, 5 plus k. Now finally, I need f of 1. So what is f of 1? When x is 1, it's here, so this is directly m plus 2. M plus 2. So what should I say? What should I say, guys? So m plus 2 must be equal to here something. So how can I express what should it be n in order to make this as defined? So isn't it, instead of n, if I say negative 3, it will be limit 3x minus 3 x minus 1 as x approaches to 1 minus, so it will be limit as x goes to 1 minus 3 common parentheses x minus 1 divided by x minus 1. So it will be simplified, so result will be 3. Now there is no problem in this case, so n must be 3. If n is 3, and 3 must be equal to f of 1, so we say that this is right now, this part is right now 3. So, and then f1 is, we said that m plus 2, so m plus 2 must be equal to 3. Then m will be equal to 1. So we have calculated m, so I need k. And so all this result is equal to 3. And then by using the logarithmic properties, 5 plus k is equal to 2 to the power of 3. And then it is 8. So k is equal to 8 minus 5, which is equal to 3. So finally, what can I say? M is 1 and k is 3. I hope that's clear for you guys. So at the beginning I said that let me wait, since when I put instead of 1 it will be 1 minus 1 0, but it says that it is continuous. It means that I have to eliminate this. How can I eliminate this if I have a x minus 1 here? To have a x minus 1, m must be negative 3. Okay, that's it. I hope everything is clear.